to your lesson on estimating lines of best fit. Here's some scatter data, and through there you can see this little red line. That's called a line of best fit. It's the line that's as close as possible to all the data points. So it's a representation of the data in a linear fashion. Notice here, as money goes up, problems go up. Oh, that is so true, isn't it? All right, so this is a very big idea in mathematics and statistics, just in the world of data analysis. Let's begin here. Here's some data. As we know from our lesson in class, this is strong positive correlation we can see. It's going up. As one variable goes up, the other one does as well. And a line of best fit might look like that. It's a line that best fits or gets as close as possible to all the data points. Here we have some data points as well. That looks like moderate negative correlation, all right? And a line of best fit might look like that. It's negative because as one variable goes up, the other variable goes down. Here we have some scattered data, definitely more scattered. So a weak negative, if you kind of look at it, you can kind of see a negative correlation. It would look like that, and maybe that would be the line of best fit, the line that's closest to all the points as possible. Here is some weak positive correlation, and the line of best fit might look like this. And this looks like there's no correlation at all. Those points are very scattered. I don't see a trend going up or down. No correlation. So here's a summary of that. We have lines of best fit for all these sets of data. Negative, 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 and no correlation. All right, so that's our job. How do you find a line of best fit? We can always just draw it kind of by estimating, but there's a process for this. Like, for example, 3 people might estimate those as the lines of best fit, but one of them would be the actual mathematically correct one. We can probably guess the green one or the blue one look closest to all the points, but how do we get the actual line? So let's take some notes. Please use the paper that was provided to you in class. The title of the paper is Scatter Diagrams and Correlation. Or something else, actually. All right, to draw a line of best fit, let's fill in the top part of your notes. You have blanks on your page where it has this. To draw the line of best fit by eye, first we're going to do something which is called finding the mean of each set of data and making what's called a mean point and plotting this point on the scatter diagram. Then we're going to draw a line that passes through the mean point and is as close to all the other points. All right, so you'll see what this process means in a moment. Here's the example problem on your page. We have a student who wants to check if there's a correlation between the predicted heights of daisies and their actual heights. So let's say there's an experiment where you had a bunch of daisy flowers and you had to estimate or predict, hey, how tall is that one? How tall is that one? And then you actually measured them and see what you got. How close are people at guessing, basically? So first step is to label the axes. Let's label this one here as our predicted height, and this one here as our actual height, because this is the thing we're controlling in the experiment, and this is the one that we want to see what happens. This actual height is dependent on the guesses here. All right, next we're going to plot the points. So take a moment now, take all these points and plot them on here. All right, is that what your scatter plot looks like? Let's describe the correlation. What do you think? That is a moderate positive. Maybe you argued strong positive. It looks kind of moderate. They're a little bit spread out. So moderate positive correlation. Now find the mean point. Okay, so the mean point means just find one point on there and add it to the scatter diagram. But that point has to be made up of the mean of the x values and the y values. So again, the predicted heights are our horizontal axis, or our x values, and the actual height are our y values. So we're going to find the mean of these ones and the mean of these ones. So first, this symbol here, by the way, means mean. Whenever you see a variable with that line above it, that's called x bar, it means the mean. So we're going to find the mean of the x values. So we're going to add all these up and divide by 14, because there's 14 of them. And the mean is this value. All right, now let's find the mean for the y values. So we're looking for y bar. We're going to add up all the y values and divide by 14 to get the mean. And the mean is 6.09. All right, so this is called the mean point. We're going to use m to represent it. There's the x value and the y value. Now we're going to take that mean point and add it to our graph. All right, so place your mean point on there. Mean point falls right about there. So does that Is that what you had? So now that we have a mean point, we can place a line of best fit. The best way to place a line of best fit, every line of best fit must pass through the mean point. So your job is only to decide how slanted is that line going to be. For example, here's a line going through the mean point, but we can have that line pointing any direction, just as we saw there, right? That line can be going in any direction, but which is the best line going through that point? Let's look at that again. So think in your mind, when should that line stop moving? When is the best line of for that data? So let's take a look at that. So let's say you looked at that and you're like, I think that's the line of best fit. So how about we all draw the same line of best fit so we have the same numbers after this. It goes through the mean point, and I made the line extend all the way here, and it intercepted the y-axis at 1. So please draw on that same line of best fit. Passes through 1 and then goes through the mean point. So a line of best fit must go through the mean point. All right, now that you have your line, let's look at figuring out the equation of this line. The equations of lines always take the form y equals mx plus b, right? M is known as our slope, and the b value here is known as our y-intercept. Any line can be written in this form. So in this case, let's find the y-intercept first. Well, that is the y-intercept. That is where the line connects with the y-axis. It's called the y-intercept. So y-intercept is at 1. So we can say b is 1 right here. So when we write this equation for our line of best fit, that b value will be 1. Now let's find the slope. To find the slope, you have to do something called rise and run. All right, so you have to see from one point on the line, so we're going to start at this point, to any other point on the line, how much does it rise and run? So I'm going to look for another point on the line that is kind of an easy one to use. And nice easy ones to use are often where they cross through the corner of the grid, like right here. So I'm going to use that point right there. All right, and I'm going to do from there rise and run. So rise, all right, and run. Make a triangle. This is called a slope triangle. Rise and run. This rises by 6 units. Let's take a look. It starts at 1 and it rises all the way up to 7. So to get to from 1 to 7, it had to rise 6 units. We can even count those. 1, 2, 3, 4, 5, 6 units. The rise is 6. Now the run, let's count those squares. 1, 2, 3, 4, 5, 6, 7. The run is 7. So the slope is always rise over run. So our slope in this case is 6 over 7 because the rise of 6, run of 7. Now we have our slope and our y-intercept. That means we can write the equation of the line, and it's going to be y equals m, our slope number, 6 over 7x, don't forget the x, plus 1, our y-intercept. So there's the equation for this line of best fit. And the line of best fit always must pass through what's called a mean point. Great. Here's the practice problem on the back of your page. Please repeat the same process and see how you do. And following that practice problem, there's a short assignment from the textbook which has you think about this skill a little bit more. So please try the assignment you find on the website. That is your full lesson. Please do your best with the homework, and we will see you soon.